Samantha or Jen, can either of you speak? Put your speaker button on and you've got the floor.
This is Jennifer. Can you hear me?
Yep, I can hear you
Yes.
fine.
Excellent. I want to welcome you to our Outbreak Narrative. I want you to first pretend you're a student. You just walked into your classroom, and in front of you there is caution tape. There are people walking around with lab coats. There are masks ready and available, and maybe in the background you hear a siren. And this is what you enter, and you sit down at your table, and on the screen all of a sudden comes an announcement, and it could be from your principal, it could be from the CDC, but what the announcement is telling you is that there's an outbreak at your school. And not only is the outbreak something that's close to you, but you're being told now that you are going to be the primary investigator. It is your responsibility to work with your classmates to solve the problem. So this is how our unit starts out, and from the very first day, from our inquiry project right through till the end to our final project, the students are involved hands-on in a very, very active way. In our inquiry projects, the students are asking questions, asking them to the students, writing down the answers, and so the communication is not just written, it's also verbal. It's about communicating, it's about developing a really great learning environment with the students and making sure that they're really motivated and excited throughout the whole thing. If you go to our slide number 2, we have several steps in our final project, and in that final project the students first are asked to come up with a set of questions themselves, and this is where the inquiry in the project is based. They come up with a set of interview questions, and then they go into a separate room where they interview a set of patients who have answers already set up. They have to write down the answers as well as have these really good questions. Then they're going to go back, they're going to analyze the data and try to talk to one another and figure out what the cause of the outbreak is. So not only are they talking with one another and communicating with each other, but they then also have to go and do some background research on their own. What kind of outbreaks have been like this in the past, and how can they look at that information to try to figure out what's happening now. The students then at the end of the project have an opportunity to report on their findings, and this is where our technology component comes in, because we also want the students to be able to choose a project that is going to work for them. So they have the option of making a brochure, they also have the option of making a YouTube video, or they can do a presentation to the class. During the research, we have microscopes set up in the room so that they can actually look at examples of the pathogen that we're investigating, as well as information there so they can compare what they see in the microscope with past outbreaks and that kind of information. When the students do present their findings to the class, the whole class does a review, and so they're engaged in a peer review to determine the quality of the research that was done as well as the presentation. But the whole thing is, again, from the beginning to the end, very active, very student oriented, and really gets everyone involved. I know that Tina and Samantha are having some difficulty with their audio in their speaking, so I just want to give them a chance if they wanted to type anything in, that they can do that now.
I think this is a very interesting model too, as with the others. You've got the students coming into the center, getting physically, emotionally involved, and you've given them lots of ways to act as scientists. So it's another very powerful lesson, and I thank you all. So I will sign off and pull on the slides for the next, but thank you very much, the Outbreak team, and we'll look forward to, I think it's the Rain Barrel guys are coming up. And I think Jay had to be away at his mentor teaching meeting. So, Billy, are you here? I think you have the floor. I'm not sure. Okay, is that Billy in the back there? Jay was coming late. Okay, yes, I said he was having trouble. Okay. Oh, Walt was involved in this too during the summer.
Can you hear me right now?
Yes. Is that you, Billy? Okay, I'm going to turn my mic
Yes.
off. Yep, you got the floor.
Okay.
Just waiting for Don to
I'm
come
just
up
gonna
here. He's
stand-
going to present the first part, and I'm going to follow with the second slide.
Do you want to get started, Ben, just in case Don's having trouble?
Yeah, I can do that. Not a problem at all. Our project is a pretty substantial project for anyone really, but it's a unit-ending project for a weather unit, and basically the project itself is a mid-latitude cyclone data collection.
Can you hear me? Because I'm ready to go.
All right, there we go. Don's there.
Okay, terrific. Thanks for picking that up. I appreciate it. So as Ben was saying, we're looking. Our overall narrative theme is natural disasters, and we chose natural disasters because it's exciting for the kids. It's an interesting subject for students and for teachers, and it's giving students an opportunity to and gives us as teachers a lot of opportunities to integrate many different aspects of weather into the class and into subsections and units. What we designed for this is a subsection that integrates extremely well with the weather unit, and it involves different aspects of weather. It's called the Mid-Latitude Cyclone Data Collection Project, and that's a really fancy name to get kids integrated with real-time weather and turning them into weather forecasters and pilots. So, working with the motivation, students get to use the same data that real weather people do. So they become weather persons, and they're going to learn that there's nothing mystical about weather forecasting. These weather forecasters are using the exact same information that these students are going to be using. The same sources to determine the weather as how we're going to run this project. So students will learn to read a weather map and how to organize, analyze, and interpret this data and use it to make their own weather predictions. We're thinking we can even turn it into a game of beat the weatherman with your own predictions. So it's going to have real life applications. As we get later into the project on day 5, we're going to have the students plot their own personal flight through a series of cities to one of the 4 destinations. So they're going to start and have to look at these complicated weather fronts, not just in the immediate region, but nationwide, and see how that integrates with their findings throughout the project. It's cohesive because it's addressing real life problems. It's looking at weather, and it can really be used in a practical way, and it lets the students get involved in something that they see on TV, and brings their intrinsic motivation level up. So the literacy integration is pretty clear cut with this. The only exception that you really have to be careful of in this kind of project is that it's very vocabulary intensive, and we need to have some kind of pre-reading activity without it, because without a basic understanding, students can get lost with low pressure systems, high pressure systems, metograms, and things like that. Also, literacy will depend on the method that they're making their presentation. Is it a written? Is it audio? Is it a combination? So each of the methods will have to answer the questions fully and completely with proper grammar and proper punctuation, and that will address the literacy on technology, obviously, computers, data online, learning how to input the data into a spreadsheet and get that spreadsheet to display different charts and graphs of this data. So that really is going to give them an opportunity to take technology, take real life, and integrate it. So real quickly, the project design is for the first 3 days. They're collecting data accumulation. They're looking at different types of weather maps. They're looking for air masses. They're looking for isotherms, isobars, pressure systems, warm and cold weather fronts, station observations, and they're starting to integrate that data and to record it. We have some specific weather sources for them, same source that pilots are using as well. Day 4, the students are getting metograms, which is a 24-hour plot of weather for a particular weather station. So that's going to come into day 5, and day 5 is the overall concept of a flight pattern for the project. I'm going to stop and hand it to Ben.
Thank you. So our second slide basically shows the data collection that the students will be doing over the first 4 days of the project. So we've got a radar image, an infrared satellite image, a surface map with fronts and low and high pressure systems shown. Those are the 3 maps on the top. The bottom left shows the weather station readings that they're going to collect on each day at each section of the storm, the cool, warm, and cold sections of the storm. And then the bottom right there, if you guys can zoom in, you can see that's an actual metogram showing a storm passing through a city, and you can see the difference in what happens with the pressure, the temperature, the wind speed, and direction as well. So this is basically the data that they would be collecting in the first 4 days of the project. And that's about it.
Thank you, gentlemen. That sounds interesting. The idea of their actually being aviators, they're really needing this data, lots of empowerment, and lots of real work here. So I think that will keep them interested and maybe get some better weather forecasters in there too. So I think we'll bring the next team up, and thank you very much, gentlemen.
Okay. Thanks, Walt. Thanks, Liz.